Good evening, madam. My name is Jason. Matrix number is AA220297. So today I will present our group PBL project. Let's getting start. So this is our group member, which is me, Jason. Next is Muhammad Haris, and next one is Nur Awanchik. So this is our content, which got introduction, filler table, problem statement, conclusion, and solution. Introduction. The application of differentiation in related rates problems involves finding the rate at which one quantity changes with respect to another quantity. These types of problems typically involve multiple variables that are related by an equation or a geometric relationship. The goal is to determine how the rates of change of these variables are connected.
Assalamualaikum, my name is Muhammad Haris Najmi bin Muhammad Nasir. Matrix number AA221705. Our problem today is you join the working man race organized by engineering department. To pass the last obstacle, you need to answer a short quiz related to mathematical problem. A pendulum of constant length LCM makes an angle with its vertical positions. If L is 17 cm and the rate of change of h is 18 cm per second, where h is the height from which the ball is released, find the rate of change of the angle theta at the instant when h is 4 cm. The content for our filler table is fact. A pendulum of constant length is LCM. Makes an angle with its vertical position. If L 17 cm and the rate of change of h is 18 cm per second. H is the height from which the ball is released. Ideas. Use the rate of change to calculate the angle theta at the instant when it is 4 cm. Use the formula rate of change theta equals angle of revolution. When the pendulum is swinging, it's form of motion which allow us to use trigonometry knowledge to obtain the required measurement. The learning issue is what is the rate of change of the angle at the instant when h is 4 cm? Which topic must be used to solve the question? What formula can be used to obtain the rate of change of the angle? What method is used to calculate the angle theta at instant when h is 4 cm? Our action plan and resource needed is research and study material on differentiation, including textbooks or online resources. Use mathematical formulas and equation to analyze the impact of length on the angle of a pendulum. Engage in discussion or seek guidance from teacher or expert in physics or mechanics. Done. The solution for our problem is h equal L bracket 1 minus cos theta, where the value of L is 17 cm and h is 4 cm. As you can see on the lower side of our solution, we already entered the value of L and h into the equation of h equal L bracket 1 minus cos theta. So the answer for that is 17 cos theta equals to 17 minus 4 equal to 3. After that, we want to find the value of cos theta, so we use the Pythagorean theorem. And the value of the cos theta is 12 over 17. After that, we want to find the sine theta, so it is equal to square root 1 minus cos square theta, and we entered the value of cos square, so we got is square root 1 minus 160 per 209. And after that, the final value of cos sine theta is square root 120 over 17. After that, we use the differentiate the L bracket 0 minus bracket minus sine theta dE per dt. And we got this 18 equals to 17 sine E dE per dt. After that, dE per dt is equal to 18 per 17 sine theta. After that, dE per dt is equal to 18 per 17 times 1 per square root 120 per 17, and it is equals to 18 per 2 square root 30, and lastly it's equal to 9 over 30 square root, and dE per dt is 9 per square root 30. The rate of change of the angle at h equals to 4 cm is dE per dt equal to 9 per square root 30 radian per second. Thank you.
Good day to you all. I'm Awan, AA220531, and this is the conclusion for this presentation. Basically, differentiation and derivative is known as instantaneous rate of change of a function with respect to one of its variables. The derivative of function x represents the rate of change of y with respect to x. It is mentioned in the units of y over the unit of x. It is also possible to the function of x to be differentiated more than once. This problem, having applied all the facts and formulas accordingly, the rate of change was discovered with the requirement of a proper thinking skills. We learned how to differentiate algebraic function and thereby to find velocities and slopes. By applying differentiation to related rate problems, we gain valuable insight into how variables interact and evolve over time. This enables us to make predictions, understand systems, and solve complex problems that involve changing quantities. By working on the project, we also learn some applications involving rate of change in real life.